Lesson 8.1 on areas of rectangles and parallelograms. Now, to find the area of a rectangle, I hope you're familiar with this formula, as you've probably seen it ever since the 5th or 6th grade. To calculate the area of a rectangle, we just take the base times the height, or the area formula looks as follows: A equals B times H. So, in a rectangle, to calculate the length of the base or the height, you would typically measure out a certain number of units. Say, for example, the base of this rectangle could be 11 inches long and the height could be 6 inches long. Now, area is a new measurement which we haven't worked with so far in geometry. Area means measuring space, two-dimensional space. Lengths, like say the length of the base there is 11 inches. That's one-dimensional. That's just like say the length along the edge of a ruler. But to calculate the area of a rectangle, we want to measure the entire space inside. So if we were to say divide the length up into 11 units and actually section off these lengths 1 inch or 1 unit at a time, you'll notice that not only do we actually create vertical units, but horizontal units as well. And then all these squares, all these spaces, we could count them. 1, 2, 3, 4, 5. And each of these inch by inch square pieces, we could keep counting until we finally count all of them. Or we could just go right to our formula. The formula of a rectangle, again, is base times height. So if the length of the base is 11 inches and the height of the rectangle is 6 inches, multiply 6 by 11 together, and we will get 66. But we also have to be careful about what unit we choose to use when measuring area. As I said before, area is not length. We're not measuring a single length, one dimension. We're actually measuring space, a two-dimensional space. And if you'll notice, each of those squares that we were counting, they're not measuring length alone, they're measuring space, area. In fact, each of those squares measures 1 inch by 1 inch, or 1 square inch. So the way of designating units when referring to areas is to write each unit of length, as we'd commonly do, say IN for inches, but then after the IN, we'll put a squared notation to indicate that the units are square inches instead of just standard inches. Now, what about the area of a parallelogram? Now, the area of a parallelogram is the exact same as the area of a rectangle. Area of a parallelogram equals base times height, or A equals BH. Now, previously in the last slide, we tried to go and calculate areas by actually sectioning off a rectangle into square units and counting up those individual square units. But as you can clearly see here, that method is rather inefficient when it comes to parallelograms because, well, since parallelograms are slanted at an angle, we can't count solid square units. There's little fractions of pieces here or there, and we really don't know for certain how much of a fraction of a square unit goes along each diagonal. So instead, let's just figure it out by using our formula. We know that the length of the base is 11 inches and that the height is supposed to be 6 inches, but, well, what exactly is the height of a parallelogram? Is it the length along this diagonal here? Not exactly. In fact, the height of a parallelogram is officially defined as the length from base to base. In fact, the distance, remember, distance measured along the perpendicular. So you'll notice that the dimensions that are being used with this parallelogram are in fact the same types of dimensions that are used for the rectangle from the previous slide. The base is lengthwise, the height is vertical, and in fact there's a reason why the area of a parallelogram's formula is so similar to the area of a rectangle. Say, for example, we were to go and take this section, this wedge of the parallelogram, and actually cut it off of the parallelogram and slide it over to the other side. Like so. What shape do we have? A rectangle. A rectangle whose base is still 11 inches and whose height is still 6 inches. And that is why we can use the area formula for a parallelogram in the same way that we use the area formula for a square. Again, area equals base times height. Base is 11, height is 6. 6 times 11 is 66 square inches. And thus concludes today's lesson.